Every single day, artificial intelligence tools are generating billions of words. They write essays, emails, and reports that sound exactly like us. And right alongside that explosion of text, a whole new industry of AI content detectors has sprung up to catch them. When you read a modern piece of AI writing, you won't find the old, obvious clues. The robotic phrasing is gone, the grammar is flawless. To a human reader, it is virtually indistinguishable from text written by a real person. If the grammar is perfect and the phrasing is natural, how does a software tool actually know a machine wrote it? AI detectors don't read your text the way you and I do. They look past the meaning of your sentences to find microscopic statistical patterns that a human reader would never even notice. This erratic EKG line represents human writing. We are naturally messy, inconsistent, and unpredictable. We have a pulse. Contrast that with machine-generated text. Large language models are designed to be statistically uniform. Their output is perfectly synthesized, without messy irregularities. When you paste a document into an AI detector, you are essentially feeding it into a math engine. The tool is simply scanning your words to see if they look like a natural human heartbeat or a statistically perfect flatline. To find that flatline, detectors look at how predictable your word choices are. In the world of AI, this measurement is called perplexity. Watch this sentence build, ending on a highly expected word. AI models operate with low perplexity, choosing the most mathematically probable next word. But humans are different. Finish a sentence with a totally unexpected word. The probability gauge drops near zero, signaling you are human. While that looks at individual words, detectors also measure the structural variation in your sentence length across the whole document, a concept known as burstiness. Humans naturally write in bursts. We might write a very long, winding sentence exploring a complex thought, and then follow it up immediately with a short punch. AI models rarely do this on their own. Without specific prompting, they default to a steady, uniform stream of medium-length sentences. There is almost zero structural variation from paragraph to paragraph. Detectors will also run a few supplementary checks, scanning for vocabulary words and smooth transition phrases that language models tend to overuse. When a piece of writing combines highly predictable word choices with highly uniform sentence lengths, the math aligns. The detector categorizes the text as AI. This mathematical approach creates a severe problem. We constantly ask students and professionals to write in ways that are clear, concise, and highly consistent. When a human sits down and naturally writes with perfect structure, tight vocabulary, and zero rambling, their text starts to mirror the very metrics detectors associate with machines. This chart compares the flagging rate among writers. It shows a massive, disproportionate spike for non-native English speakers. Because they often rely on careful, formal, and structured phrasing, detectors heavily penalize them, mistaking their learned precision for the high predictability of a machine. The exact same thing happens to technical writers, scientists, and lawyers. Their fields demand standardized formatting and precise terminology. As a result, their human writing triggers false positives. We also step into this trap when we use grammar checking software. Running a rough draft through a tool to fix spelling and flow actively smooths out the natural irregularities in our writing, effectively erasing our human rhythm. Making matters even more complicated, developers are now building humanizer tools. These programs take AI-generated text and deliberately inject fake mathematical messiness into the sentences, specifically to trick the detectors. Ultimately, these detectors are measuring statistical perfection, not true authorship. Innocent writers who prioritize clarity are routinely caught in the crossfire. These statistical flaws have severe consequences. False positives lead to destroyed careers, failed classes, and stressful academic accusations. The error rates are so measurable that major institutions like Vanderbilt University and Australia's Curtin University evaluated the data and completely disabled their default AI detection tools. This gives us a firm baseline for how we must handle these tools moving forward. A high detection score should never be used as singular proof of cheating, and it is certainly not grounds for termination. Instead, if you must check a document, run the text through multiple different detectors. You are looking for a consensus across several platforms, rather than blindly trusting a single tool. Look past the big percentage score at the top of the screen. Examine the sentence-level breakdown. Look at the context of the writer's background and ask yourself if they were simply following a strict grading rubric. The most effective solution to a suspicious detection score is direct human communication. Before deciding, sit down and have an open conversation with the writer. AI detectors provide a check engine light. They alert you that something in the structure is worth looking at. They are the start of a conversation, not a final, undeniable guilty verdict.